So hey guys, can you hear me or not? I just plugged in my computer and turned on. So let's get started. And I hope you guys can hear me, okay? So I know there is a kind of peace voice right now, the high peace voice. I don't know if it's problem with the jack or what, but it's showing problem right now. So please guys adjust, okay? As you can see, the high pitch voice has been lowered. So let's get started with the starting and okay, let's get started. States of matter. Matter is mainly classified into three types: solid, liquid, and gas. Solid. It has been defined and fixed shape. Size and volume. Particles are compact and fixed in structure. Are packed and compact in the structure. Fixed in structure. Sorry. Solid. It has defined and a fixed size and volume. Particle are compact, fixed in structure. Liquid. It has closely fixed particle and does not have fixed in structure. Gas. It has free and far away particles from each other. It has closely and far away from each other. Closely and far away from each other. This was the gaseous state. The gaseous state is a fundamental phase of a material defined as widely spaced, freely moving particle within the exhibable attractive forces properties of gaseous state. Gas, uh, gas, uh, Gases can be compressed. Gas can expand when it loses loss pressure. Loss pressure is applied. Gas can be mixed. Gas can exert at a constant temperature on its container walls. Wo- laws of gases. The relation between the pressure, volume, and temperature of any gas is expressed in terms of different laws, which is known as law of gaseous, gas law, gas law. It varies. The various gas law are as follows: Boyle's law, Charles law, Avogadro laws, Danton's law, and Danton law of partial pressure, Graham's law. Graham's law of diffusion. Boyle's law. The statement of the law states that at the constant temperature, the volume of given mass of gas is inversely proportional to the pressure. Inversely proportional to the pressure. Inversely proportional to the pressure. Boyle's law may be stated as the product of the pressure and the volume of given mass of gas in constant temperature at a constant temperature. Let P1 and V1 are initial pressure and the volume of gas P2 and V2 are the final pressure. The volume at constant temperature, then the according to the Boyle's law, P1 V1 is equals to K and P2 V2 is equals to K. From equation I P1 V1 is equals to P2 is P2 by V2. This equation 4 is the mathematical theory of the Boyle's law. Graphical repetition of Boyle's law. Volume versus pressure graph. Volume versus pressure graph. When the volume is plotted against the pressure at the constant temperature, the hyperbolical curve is obtained, which indicates that the volume is inversely proportional to the pressure. This graph verifies the Boyle's law. The volume versus reciprocal of pressure. The reciprocal of pressure at the constant temperature or a straight line passes through the origin as shown in the figure. The graph verifies the Boyle's law. The graph verifies the Boyle's law. Wait, verifies the Boyle's law. Um, product of volume and pressure versus pressure. When the product of the volume and pressure is plotted against the pressure at the constant temperature, a straight line parallel to the pressure axis is obtained. The graph indicates that the PV value remains constant. This graph verifies the Boyle's law. Relation between the pressure and density of the gas, mass by volume, D is equals to m by V, and V is equals to m by D. At the initial state, V1 is equals to P D m by D1. At the final state, V2 by m V by 2. Okay. Okay, where the pressure is in directly proportional to the directly proportional to the density of the gas. Significance of Boyle's law. Boyle's law shows that the relationship between the volume and the pressure of gas in constant temperature and the mass in i.e. V is inversely proportional to 1 by P. Boyle's law shows that the relation between the pressure and the density of gas in constant temperature and mass is which means that pressure is inversely proportional to the density. Why do the mountaineers carry oxygen? The cylinder within them in at the higher altitude I at them at a high altitude. It states that at a constant temperature, the volume of the given mass of gas is increased or decreased by 1 by 273 parts of its volume at 0 degrees Celsius for each degree Celsius rise or falls in the temperature. At DOBB, the volume of the given mass of the gas at the 0 degrees Celsius, then the according to the Charles law, the volume of gas at 1 degree Celsius, VO plus 1 by 273 degree Kelvin, degree 1 million, Kelvin, just K 1 into the VO 1 plus 1 by 270 Kelvin. Let P1, V1 and V2 are the volume of gas given mass of gas at the temperature T1 and T2 degree Celsius respectively. Then the equation becomes V1 is equals to VO plus 1 by 1 plus T1 by 273 degree 73. V is inversely to the time. Charles' law may also be stated as at a constant temperature, the volume of given mass of gas is directly proportional to the temperature. Absolute zero temperature, the volume of gas at T degrees Celsius. V is equals to 1 plus T by 270 degrees Celsius. Volume of gas at minus 270 degrees Celsius is equals to VO bracket 1 minus 273 by 273 VO into 0 or 0 meter cube. The value of absolute zero temperature is minus 273 point 15 degrees Celsius is the absolute zero temperature value is the true absolute zero value. True absolute zero value. Hmm. The temperature minus 273 degrees Celsius or minus 273.15 degrees Celsius, as which the volume of all gas becomes zero. In fact, the absolute zero temperature, in fact, all gas becomes liquid or solid. Before this, the temperature is reached. At this temperature, the molecular vibration ceases to exist, and the molecules have no kinetic energy or known velocity, and occupies no volume. Theoretically, graphically representation of zero temperature, it means that key all the elements or all the elements who exist in the earth when it is cooled down or brought near the temperature called minus 270 degrees Celsius, 15 degrees Celsius, is liquefied or solidified before this temperature is even reached. Okay, this is called the absolute zero value. This is also called the absolute zero value. Volume versus temperature. The volume versus temperature shows that the volume is to be closest or lowest in this point, and the temperature will be in the lowest point also, and gradually increasing the temperature also gradually increase the volume of the element. Graphical representation of the Charles law. The volume versus Kelvin temperature scale. When the volume of gas is plotted against the temperature in a Kelvin at the constant temperature, the straight line is passing through the origin is obtained. These graphs verifies the Charles law. The volume versus Kelvin in a temperature scale. The volume of gas V and the temperature T in the degree Celsius graph. When the volume of given mass of gas V is plotted against the temperature degree Celsius at the constant pressure, at the straight line is obtained, which verifies the Charles law. When the straight line is extrapolated, the line meets the temperature axis at the minus 270 degrees Celsius, where the volume of gas becomes zero. This temperature is at minus 273.15 degrees Celsius. 0.15 degrees Celsius. Standard temperature or pressure and pressure. Standard temperature and pressure. The temperature degree Celsius, degree 0 degree Celsius and 1 atmospheric pressure or 760 mm of Fg are called the standard temperature and the pressure as Tb, or normal temperature and pressure and Tb. The relation between the temperature in a degree Celsius and the temperature, we have T is equals to small t plus 270 degrees Celsius 3 by bracket mark Kelvin, where T is temperature in Kelvin scale and small t represents the temperature in degree celsius. Combined gas law, P1 and V1 is equal by T1, P2 by V2 is by T2. The combined gas law can be derived by a combining Boyle's law and Charles law. According to the Boyle's law, at the constant temperature, the volume of a given mass of gas is inversely proportional to the temperature. V is inversely proportional to the 1 by P at the constant temperature, where V is equals to volume of gas, P is equals to pressure of gas. According to the Charles law, at the constant temperature, the volume of a given mass of gas is directly proportional to the absolute temperature. V is inversely to T, where the V is volume is given mass of gas, and small t absolute temperature is the absolute temperature. Combining equation I and II, we get V is inversely to the T by P, and V is equals to the K. K represents a constant, proportionally a constant, right? K is K into T by P, or PB is equals to KT, or PB is PB by T is equals to K, which is II, where the K is proportionally a constant. Let P1 and B1 and T1 are initial, and P2, V2 and T2 are the pressure and volume of absolute zero of the given gas respectively. Then the equation II becomes P1 V1 by T1 is equals to K, or P2 V2 by T2 is equals to K. From the equation of IV and IV, P1 and V1 by T1 is equals to P2 by V2 by T2. The equation is combined gas law in the terms of density from the Boyle's law. P1 and V1 by T1 is equals to P2 V2 by T2. Or you can also, in the terms of density, we can also say that P1 into M by T1 into density 1 or T1 is equals to P2 into mass by time or temperature into density, or P1 by D1 into T1 is equals to P2 by D2 into T2. Ideal gas equation. Ideal gas can be derived by a combining Boyle's law and Charles law. According to the Boyle's law, at the constant temperature, the volume of a given mass of gas is inversely proportional to the pressure. I.e., V is inversely proportional to the inversely proportional to the 1 by P, or reciprocal of pressure, where V is the volume of pressure and P is the pressure of the gas. According to the Charles law, at the constant temperature pressure, the volume of a given mass of gas is directly proportional to the absolute value. V is inversely proportional to the T. At the constant temperature, where T is equals to K, means K represents a proportional constant, combining equation I and II. V is inversely proportional to the T and P, and V is inversely to the K and P, and P Vb is equals to Kt, where the K is proportional to the constant and its value depends upon the mass of the gas taken. If the 1 gram of gas is called a specific gas constant, and its value is different for different gas. If the 1 mole of gas is taken, the value of constant K becomes same for all the gases, and it's called universal gas constant. So for 1 mole of gas, K can be replaced by R, which is the universal gas constant. Equation becomes PV by RT. And if the n mole of the gas is taken, equation IV, the IV becomes PV is equals to nRT. The equation V is called the ideal gas equation, where the K is the universal gas constant, where the K is the universal gas constant. Significance of universal gas law, gas constant. From the ideal gas equation, RV is equals to NR, PV is equals to R and T. R is equals to PV by and T, or F. Oh, means R is equals to 4 into force into length by the number of moles into temperature in Kelvin. Value of R in the different unit: 0.081 liter of atom per molecule per Kelvin is equals to R, means U bio CIC Jamma U org molecules, which is also called CGS temperature. As now 8.31 by 4 into 10 to the power 7 org per mole by Kelvin. होइन यो भइसक्यो टेम मोड्युल त्यसपछि 8.31 पर मोल बाई पर केल्भिन इज सिएल एसआइसी युनिट एसआई युनिट अनि त्यसपछि 1.987 क्यालोरी पर मोल पर केल्भिन इज इक्वल्स टु के ओके Okay, Danton's law of partial pressure. It states that at a constant temperature, the total pressure exerted by a mixture of non-reacting gases its mixture is non-reacting gases is equal to the say sum of partial pressure of individual gases. Let P1 and Pa and Pv be the particle pressure of the two non-reacting gases, and the Pt can be the total partial pressure of the gaseous mixture. According to the Dalton's law of partial pressure, Pt is equals to Pv plus Pa plus Pv, where the Pa is partial pressure of gas A, Pv is equals to partial pressure of gas B, Pt is the total pressure. Mathematical derivation of Dalton's law of partial pressure. Let us consider two non-reacting gases, that is P and V, having number of mole A, Na and B respectively, are enclosed in a single vessel of volume B at the constant temperature T. Let Nt be the total number of mole of gaseous mixture, and the total number of gaseous mixture is given by Nt is equals to Na plus Nb. I from the ideal gas equation, PV is equals to nRT, and N is equals to PV by RT. For gas A, PA is equals to PAV by RT. For gas B, and B is equals to BB by V is equals PV PV by PV P P V by RT. For the gases mixer, anti is equals to PTV by RT. Substituting all the values of equation IV, get PTV by RT, and P is equals to PV by, okay, कति धेरै हो, means PT is equals to PA plus PV. This equation mathematical derivation of Dalton's law of partial pressure. Danton's law of partial pressure, the application of Danton's law of partial pressure. It is applicable in the calculation of the pressure of dry gas. Dry gas P means moist gas is equals to P dry gas plus water vapor. Okay, it is applicable in the stream distillation process. The partial pressure of individual gas is required to calculate the equilibrium constant. Define the partial pressure of the equisonic tension. Partial pressure is the pressure on the individual gas in a mixer would exert if occupied it, if it occupy the entire volume of mixer on its own. Aqueous tension in the partial pressure exerted by the water vapor in the most gas. It states that at a constant temperature, the total pressure exerted by a mixture of non-reacting gases is equal to the sum of partial pressure of the individual gases. Let PA and PV be the particle pressure of two non-reacting gases, and PT be the total pressure of gaseous mixture. According to the Dalton's law of partial pressure, PT and PV plus PV. Okay, where PV is the partial pressure of gas A, and PB is the partial pressure of gas B, and PT is the total pressure. The total pressure. Determination of linear expansion of solid by Pulliger's apparatus. It is based on the thermal expansion of a solid expand on heating. Experimental setup. This experimental setup is shown in the figure. It consists of the hollow metallical tube, rod AB, and spirometer, and the electrical current. Initial reading. Initial length of the rod, that is L1, is measured with the help of the scale. Central leg of the spirometer is rotated downwards until the galvanometer shows the deflection and the corresponding reading of the spirometer C1. The initial temperature of the metallical rod, that is Q1C, is measured. Center leg of spirometer is rotated upward to provide gap for the expansion. Final reading, the metallical rod is heated by passing steam through the intel until the steady state is obtained, and final temperature, that is Q2, is recorded. Central leg of spirometer is rotated downward until the galvanometer shows deflection, and corresponding to the final reading, the spirometer is recorded as 2. Heat is the form of energy. Calorimeter. The according to this theory, the heat is the invisible, weightless or outdoors fluid, which is called calorie. Dynamic and molecular theory. According to this theory, the heat is the total sum of kinetic energy possessed by the molecules of means of transitional and vibrational and the rotational motion. More about heat. V is equals to Ek plus Ep. The sum of all types of energy is called internal energy. The total energy by means of motion is called the thermal energy. Non-mechanical transfer of thermal energy due to the temperature difference is called heat energy. Heat is the thermal energy is transmit. Absolute content of heat cannot be measured. Heat of body or heat in the body is business. A device used to measure heat is called calorimeter. It is derived unit. It SI unit is joules. It is CGS unit is calorie. Change of heat or causes heat or effects of heat or any effects of heat. Effects of heat. Become something to write. Is this effects of heat? Change in temperature, change in volumes, change in the state of matter, change in state of matter. Effects. Uh, change in volume, change in state of matter, change in physical properties, change in chemical properties, production of electricity and production of light. Temperature is the effect of heat. It is measure of average the kinetic energy of per molecule. It is the fundamental and descriptive properties of the basic property. The property which determines the direction of the flow of the heat is called temperature. The property which decides the temperature, whether the systems are in equilibrium or not. The device used to measure the temperature is called thermometer. The COFO and K or KRO, degree R and degree RN are the different temperature scales. The temperature in the volume is indefined. The absolute zero and the triple point as standard fixed point temperature is modern thermometer, thermometer, thermoequilibrium. The state of liquidity in the temperature is called thermoequilibrium. Zeroth law of thermodynamics. It is the fundamental law in the thermodynamics which gives the ideal temperature measurement of the temperature. It states that if two systems are separated by a thermal equilibrium, within the third system, when they must be in the thermal equilibrium with each other. They must be in the thermal equilibrium with each other. Proof. Let us consider that three thermodynamic systems IE, A and B and C having final temperature T1, T2 and T3 respectively. Since A and B are separated with C by conducting wall are separated by C by conducting wall, so they are in thermal equilibrium. T2 T1 is T3 and T2 is equals to T3. From the equation I and II, we get T1 is equals to T2. The system of A and B are also in the thermal equilibrium, even if they are if even they are separated by insulating well. Significance. According to the zeroth law of temperature, it is measurable property which decides the whether the systems are in equilibrium or not. Thermometry, the branch of physics that deals with the study of measurement of the temperature, is called thermometer. Device used to measure the temperature is called thermometer. essential requirement to prepare the thermometer. They are essential requirement to prepare thermometer. They are construction, calibration, and sensitivity. Construction. Proper choice of working substances is called construction. For construction, there is a proper choice of working substances, such as those whose measurable physical property may vary within the change in the temperature. So guys, I'm gonna eat. So eat my breakfast for a sec. So I will be back in 15 minutes. So bye bye. Not bye. Just wait over here. Just you guys even watch. Okay. So guys, I'm back. So for starting, let's get started. Okay. So let's go, guys. Let's start studying. Let's don't waste time, man. Let's Let me see my phone battery percentage. Which is being used as 8 to 20%. Okay, it's charging. Okay, it's charging. So let's get started. Okay. Mm. By the way, guys, we're gonna hit 1 hour, 1 hour of streaming soon. So congrats to all for being over here. Sorry. So let's get started. Thermomaterial, the branch of the physics that deals with the study of measurement of the temperature is called thermometry. The device which is used to measure the thermometer is called a thermometer. Essential requirement to prepare the thermometer are they are essential requirement to prepare the thermometer. They are construction, calibration, and calibration and sensitivity. I don't know. There is a kind of lag on this device. Uh, Yesterday was pretty good. No lag, but I don't know what is over today. I just saw the live cam footage and it is kind of lag. Yeah, we can do nothing about this stuff. Yeah, keep on starting. Okay, nothing we can do. Mm. Mm. The branch of the physics that deals with the study of measurement of the temperature is called thermometer. A device that is used to measure the temperature is called thermometer. Essential requirement to prepare the thermometer. There are three essential requirement to measure the temperature of thermometer. They are construction, calibration, sensitivity. Construction. Proper choice of the working substances is called construction. For construction, they are proper choice of working substances such they are whose whose one measurable physical property may vary with change in temperature. With change in temperature. Calibration is the process of providing scale for newly construction thermometer, which is called calibration. For calibration, upper fixed point and lower fixed point are provided. Lower fixed point and higher fixed point is provided. For calibration, upper fixed point and the lower fixed point are provided. Lower fixed point, the temperature at which the pure ice just melts under the standard atmospheric pressure is called lower fixed point. It is the also called the melting or ice point. Upper fixed point. Upper fixed point is at which the water boils under the standard atmospheric pressure is called upper fixed point. It is also called the boiling point or string point. Sensitiveness. It is defined as the ratio of change in this physical property per unit change in the thermometer. At the thermometer is said to be more sensitive if it is measured in the small range of temperature. It measures temperature in a short interval of time. Note: sensitivity can be increased by making large possible surface area of the bulb of thermometer, using narrower capillary bore, using thinner wall of the bulb, thicker wall of the bulb of thermometer, changing the working substances of high uniform coefficient of the thermal expansion. It is defined as the ratio of change in the physical property per unit of change in the thermometer. Different change in different temperature scales. They are different temperature scales. They are Celsius scale, Fahrenheit scale, Kelvin scale, Kelvin scale, etc. Thermal expansion. The tendency of increase in the shape and size dimensions of the object is called thermal expansion. Causes of thermal expansion. Each atom of the matter vibrates about their mean position when the thermal temperature increases. Kinetic energy and the vibration of the atoms also increases. Due to this, average distance between the atom also increases, which leads to the increase in dimension. This is also called the thermal expansion. Expansion of solid. Since the solid has a fixed shape and the size, so it consists all three types of thermal expansion: linear thermal expansion, superficial thermal expansion, cubical thermal expansion. Linear thermal expansion. To increase the length of an object due to the change in the thermometer is called linear thermal expansion. It is also called the one dimension thermal expansion. Let's take an example of scale. Okay, a metal scale. Okay, metal scale has a length of 5 centimeter, and when it is heated to a certain degree and its volume is increased, it is called the when the only its length is increased, it is also, and then it is called one dimensional thermal expansion only. Definition. Superficial thermal expansion. The tendency of increase in the view area due to the change in the temperature is called superficial expansion of superficial expansion. It is called the 2D thermal expansion. Q1 and Q2. Let's take a square, a metal square. When it's heated, both its length and the breadth is increased. So we can say that it is two dimensional thermal expansion. Two thermal dimension of expansion. Relation between alpha and gamma. Let us consider that the metal cube of initial initial length L1 and initial volume V1 at the Q1C, when the metallical tube is heated at Q2 0 degree Celsius, so that it is final length of the volume becomes H2 and V2 as shown in the figure. Then the form the figure, V1 is equals to L1 3, and V2 is equals to L2 by L2 cube II. V2 is equals to V1 by 1 plus alpha delta beta alpha delta and beta theta is just okay. uh, Alpha means linear expansion, and see gamma means cubical expansion. The elements of the periodic table discovered, okay, 818 elements. From them there is 62 natural element, and 18 of them are artificial mixed element, artificial out, okay, obtained elements. 60 94 94 भनेको naturally find हैन, अनि 64 are artificially obtained. Periodic table are also are the systematic element of the elements of the basis of in which the elements is shown in the property are replaced by the separated from each other. History. Antonium Lavestor. Lavestor is the first person in is to classify the elements in the 18th century. He classified the elements into metal and non-metals. Lobateler tried John Gobetter, English chemical. He observed that the property of element known at the time and made of the triad of three elements having the similar properties. No. Okay, Maldives periodic table. Dermit periodic table 1869 statement. Properties of the elements are the periodic function of their relative atomic mass, both chemical and the physical properties. The periodic function is the repetition of the property of the element in the certain interval, and nine group in the modified Maldives, but its group in original because inert gas were not discovered. Inert gas were not discovered. Advantages of periodic table. Systematic study of element, then backend box were placed for the future new discovered element. Correction of some element masses. Disadvantage. Position of hydrogen gas shows 1a and vi property. Position of isotopes and isobar. Isotopes are those atoms which share same atomic number but different atomic mass. For example, hydrogen isotopes. Argon and potassium elements have a massive problem where the argon has 39.9 AMU and potassium have the 39.1 AMU. Cobalt and nickel inverse order of their relatively atomic masses etc are the abundities features to study the properties of elements systematically arrange periodic function of the relative atomic masses, 9 group and 7 periods further into the non further into subgroup also VII and group had 3 elements. Modern periodic table, Henry Moseley, 1913 AD, statement the physical and chemical property of an element. They are the periodic function of their atomic function. Rough structure. Rough structure is the features. They have 7 year horizontal row called period, and each period begins with the electrical cell entering new cells. First periodic table contains 9 elements, shortest period. Second and third contain the 8 elements, short period, and fourth and fifth contains 18 elements, long period. Sixth and seventh periodic contains 32 elements, longest period. They are 18 vertical columns called the groups. Each groups contains a set of elements having some number of valence electron. Lanthanides 18 58 by 271 and lactanides 90 to 103 are placed below the same same table left proportional of the periodic table contain high reactive metals, whereas right position controls highly reactive non-metals, and middle proportional contains transition elements. They are called 4 blocks SPDF. Merits of modern periodic table. Modern periodic table is based on atomic number, which is more fundamental property of an element. Atomic number relates the electronical configuration of element so that it explains about periodicity. Chemical different elements have been placed in different groups. It removes the anomalies about the position of isotopes which exist in the Maldives periodic table. In the modern periodic table, isotopes are placed in same place. The confusion about the anomalous pairs AR and before K Co before the CI nickel is well justified based on the atomic number. It also separates the metallic metals and non-metals. Elements are divided into different blocks based on differentiating electron SPDF block. Demerits of modern periodic table. Position of hydrogen. Hydrogen resembles both the property of halogens and alkali metals. However, it is placed in the separate box just above other elements in the group 1. Position of helium. Position of helium along with the p block element is not completely justified to be in the s block. Position of lanthanides and actinides. The table is unusable to include the lanthanides and actinides in main body. Why modern periodic table is more superior than Maldives periodic table? Why do you mean by the periodicity? Why does it occur? Periodicity refers to the phenomena of where when the properties of elements after a fixed point regular intervals are similar are called repetitive. This occurs due to the similarities among the outermost electron configuration of the said elements. It occurs because because the property of an element is governed G by its outer electronical configuration. After certain interval elements having similar outer electronical configuration reappears. Thus, periodicity occurs. Classification of elements into different blocks on the basis of the orbitals into the into 4 periodic blocks which different electron enters elements are classified into SPDF block elements as block elements in which differentiation differentiating electron. Last electron enters the s block of outermost shells are called s block elements. Belonging to the group I and group II are called the s block element. Characteristics of s block element: the general outer electronical configuration is ns1 minus 2, where the n is the number of cells. They are highly reactive soft metals. They can easily be caught by using knife. They have low melting point. Classification of basis of let's go. Classification of basis of incomplete cells and Boros classification. Null gas or inert gases. No normal representative of elements and transmission element. Inert transmission element. Noble gas or inert gas. They have completely filled cells, or they are or the elements with zero incomplete field cells. Elements of group 18 are noble inert gas. Normal or representative elements. Elements having one incomplete cells are called the normal representative elements. All elements of S and P block element 18 are representative element. Transition element, they have incomplete cells. Elements of D blocks are the transition elements, are called the transition element, are called the transition element, are called the transition element. Inner transmission, they have three incomplete cells and elements of lanthanides and actinides, F block element. IUPAC classification, the groups are are numbered from 1 to 18. Periods are numbered from 1 to 7. Provide systematic classification of avoiding different disparity between the different method. Boron's law, the classification nuclear charge and effective nuclear charge J. The electrostatic force of attraction that exists between the positively charged nucleus and negatively charged electron is called nuclear charge. It is detonated by G, and the screen effect, the shielding effect, the representation provided by the inner shell electron to the outermost electron against the nuclear attraction is called shielding or screening effect. Due to the shielding effect, the valence or electron shells are less attracted to the nucleus. It is measured as the shielding constant, as a shielding constant. Bro, I'm sending, I'm spending some burned stuff. So congrats all, we have just hit 1 hour of streaming. So congrats all who has been sitting over here watching me studying. So yeah, thanks so much. Effective nuclear charge. The effective nuclear charge is denoted by Jeff. Jeff. The nuclear charge attraction experienced by the valence electron is called effective nuclear charge. It is denoted by Jeff and calculated as effective nuclear charge. Effective nuclear charge minus Fielding constant. Periodic table and periodicity. The periodic tends reference to the pattern of regularities in the property of an element as we move across the period or down a group. Atomic radical and ionic radical. Ionization energy IE and ionization potential, electron affinity and electronegativity EV. The metallic characteristics, atomic radical and ionic radical. The shape of the atom is sphere, so it detonates by the term radius. Atoms and ions radius is defined as the distance between the center of the nucleus and the outermost shell is an atom or ion. It is impossible to determine the radius of different form of isolated atom due to the following reason. It is difficult to isolate an atom and measure its radius. According to the wave mechanics, electron cloud do not fix boundary. The size of an atom is also affected by the types of near and nearly atom and nature of bounding. Before bonding one मानेगा. Okay, atomic radius is calculated indirectly from the bond length. bond length and measurement. Covalent radius, metallic radius, Van der Waal radius, ionic radius. The strength of the various bond is in the order: covalent bond, metallic bond, Van der Waal bond. Covalent bond is the strongest, hence is a blended between the pooled closely. Therefore, the measured distance is small. Similarly, Van der Waal bond is force of attraction is weak, hence the atom are pulled so the closely, and the distance between the s atom is large. Order of radius: van der Waals radius, the metal radical and covalent bond. Factor of affecting atomic radicals: so in the cell C, the principal atoms number and effective nuclear charge. Covalent bond: it is the half distance between the two nuclei in the homonuclear diatomic molecule, bounded by a single covalent bond given in the figure. Covalent bond is the strongest, hence the blended atoms are glued closely. Therefore, the major distance is small. Similarly, van der Waals bond forces of attraction is weak, hence the atoms are pulled so closely, and the distance between two atoms is large. Order of radius: van der Waals radical, metallical radical, covalent radical. The factor affecting the atomic radical: number of cells, principal atomic number, effective nuclear charge. Covalent radius is the half the distance between the molecule bonded by a single covalent bond given figure. Metallical radial: it is the half distance between the two nuclei by the metallical bond. Van der Waals radius: it is the half the distance between two non-bonded nuclei of the atom held together by Van der Waals force of attraction. Van der Waals force of attraction. Factor affecting the atomic radius: the number of cells. As the number of cells increases, cells increase, the atomic radius shows the increasing effective nuclear charge. As the effective nuclear charge increases, the valence electron are almost strongly attracted towards the nuclear. As a result, the size of an atom gets contracted, which decreases its atomic radius, and vice versa. mm, Variation atomic radius in a period: when we form left to right in a period, nuclear charge increases by 1 unit and electron is added to same unit, hence the electron are attracted more strongly by the nuclear, due to which the size of atom decreases across the given period. Variation of atomic radius in a group: when we move from at top to bottom in a group, the nuclear charge go on increasing along with the addition of new cells. This decreases the depth due to the shielding effect, as the results of size of an atom increases as we move down the group. So similarly, हामी के भन्न मिल्छ भने summary of C and D is that ग्रुपमा के हुन्छ, एटमिक रेडियस इन्क्रिज हुन्छ र पिरियडमा एटमिक रेडियस घट्छ. Oh, so tired. Defined as the distance between the nucleus of an ion up to it has influence on its electron cloud. It is also measured by measuring the distance between two nuclei of bonded ions. By the study of ionic radius, following the conclusion are made: the cationids is smaller than the parent atom. The ions is larger than its parent atom. The size of a catenoid is decreased with the increase in the positive charge. In isoelectric electronic ions, the size of ions is decreases within the increase in the nuclear charge. Cations is smaller than the parent atom. The cation is formed by the removal of the one or more electron from an atom. The parent atom is because due to the with the loss of one or more electron valence shells is also removed by the nuclear charge remains same as the atom, which increases the effective nuclear charge. So charge thus the size of a cation is smaller than the parent atom. Parent atom, okay. Nuclear charge as electrical charges decreases and increases as electronical charge also size decreases and increase the nuclear charge. Ionization energy is defined as the minimum amount of energy required to remove an alkali particle or a element. On an element, it is measured in the it looks like my brain is tired by studying like how many hours? By 1 hour and 30 minutes straight. Wow. So guys, right now I'm gonna test something. Is that to share my screen? Okay, to share my screen. Is that good? So, wait a sec. Okay. Mm, wow. You guys can see my screen also. Anyway, so so let's go to YouTube and I'm just testing right now. Does does this thing really works or not? Does this thing really works or not? The audio, because the speaker is gone for right now. So for this, I'm gonna share my screen. I'm gonna share my screen for a while. Let's see. Okay, let's see for a minute that you guys can see my screen or not. Okay, so right now this screen is sharing. Okay, so I don't know you guys can see my face or not. So I'm watching this video. Okay? So I want to watch some videos. Oh, okay. Yes. The I think there is a lag, not in lag, but lag in computer power. Because my computer has not much power, and yeah, you can see the recommendation. I don't know. guys can hear me or not because my speaker is on my end is on and I cannot hear the audio of the video. I'm trying to make it on, make it listen to the audio. I cannot hear the uh, and yes, I used to wait while I be trying. Sorry guys, there might be some bit trouble. As I told you guys, there was some computing power lag, and my of course my the video is gone actually. So it will be improving by minutes. So you can see it has been lot improved by up to now right now. Yeah, and my phone battery percent is increased by 20. So I start the stream when my phone was in 8%. Now it is in 28%. So I just want to see that uh the phone was charging and the screen share thing works or not. So yeah, thank you so much. Okay. Yo, actually, guys, I don't get that the voice under the it's showing the green bar, but I don't get it. Okay, I don't get it actually. And yeah, you can guys hear me. Okay, you can guys hear me. So let's go back to the streaming. It was a quick, it was like a quite a break. So yep, it's already been 1 hour and 17 to 18 minutes. Now we are touching the 18 minutes, and it is 8 8 8:36 a.m. So yeah, let's get started. Okay. Okay. Ionization energy is defined as the minimum amount of energy required to remove a mostly loosely bounded electron from a located genus atom. Ionization is also called the ionization potential because it is measured as the minimum potential required to remove and a minimum potential required to remove and a mostly loosely held electron from rest by an atom. It is generally represented by the electron volt EV. Mm. Factor affecting ionization energy: the size of an atom or the ion. As the size of an atom increases, the atomic atom increases are less attracted by the nucleus and less amount of energy is required to remove an electron. Hence, the ionization energy is decreases with the increase in the size of an atom. Example: ionization energy is in order means lithium is greater than lithium has more ionization energy than the sodium, and sodium has less ionization energy than the potassium. Okay, knowledge is greater than the potassium. The electrons are lesser to attract to nucleus. The atom of okay. Nuclear charge. As the nuclear charge of an atom or ion increases, the electrons are more strongly attracted towards the nucleus, and the more energy is required to remove an electron. Thus, the ionization energy electron E increases with the increase in the nuclear charge. Screening and shielding effect: greater the number of electron or the shielding effect, higher will be the shielding effect. As the screening effect increases, the balanced electron feels the attraction towards the nucleus and cells less electron is required to remove the electrons. Hence, the ionization energy decreases with the increase in the shielding effect. Penetration effect of the electron for the given cell. It is followed that as electron is more closely to the nucleus. Thus, p cell electrons and the p electrons are closely than the d electron, and so on. Therefore, the s electron are more strongly attracted by the nucleus than the corresponding p electron, and so on and so on. So on. Thus, the ionization energy is in the order. Electronic conjugation. The half-field orbitals are more stable than the partial field orbitals. Hence, the highly ionization uh, energy required to remove an electron from the completely half-field electron orbitals compared to the partial field orbitals. Hence, the ionization energy is in the order. Variation of ionization energy across a period. On the moving from left to right in a period, the nuclear charge increases and the size of an atom decreases due to the fact due to the which the electron is more strongly attracted to the nucleus, and the more energy is required to remove the electron. Ionization energy increases the across the period. Variation of ionization energy across a period. On moving from the left to right in a period, nuclear charge increases and the size of an atom due to which the electron are more strongly attracted by the nucleus, and more energy is required to remove the electron. Ionization energy increases across the period. Variation of ionization energy across a group. On moving from top to bottom in a group, nuclear charge decreases and the size of an atom increases due to which the electrons are loosely attracted by nucleus, and less energy is required to remove the electrons. Ionization. Ionization increase the energy decreases across the group ionization energy period. Note concept of ionization energy. Alkali metals have low conception means demerits of ionization, or the consequences of the ionization energy. Consequences of ionization energy. Note consumption of ionization energy. Alkali metal have low ionization energy in a period, as it have a large size of large size among the others except the inert gases. Noble or inert gases have highest ionization energy value in a period. Due to the its it is due to the its stable, completely highly filled electronic configuration. The ionization energy of an nitrogen is higher than the outer than the oxygen. It is due to the half field electronic configuration of nitrogen, as half field orbitals is more stable than the partial field orbitals, i.e. Of the B is more than the B, it is difficult to remove electron from the s orbitals to p orbitals. Electronical affinity. The energy released when the atom is into the isolated gases atom to form an ion is called electron affinity. It is a tendency of an atom to form an ion, so it is greater than the tendency of an atom is called atom to add, except the tendency of an atom to add or accept tendency of an atom to add or accept, the higher it will be the electronical affinity. The energy released when the electron is isolated from the gaseous well, ion is called electronical affinity. Sorry. I think we might hit the 1 hour and 30 minute mark soon. So yes, guys, I don't know if the video is kind of lagged. I'm sorry for that. I don't know what is going on. Yeah. So let's begin. Okay. So yeah, we can literally do nothing. I think probably from next stream I will like manage this stuff. So up to 1 hour and 30 minutes, there is no viewers. I can see for that sure. And yep, this is not great. This is not great actually. So literally you cannot do nothing for right now. So keep on starting. So yeah, as you can guys see, it is already 8:46 p.m. a.m. Sorry, a.m. So I gotta start. I gotta go in 1 hour or one not 1 hour in half an hour. So yeah, this tricks continues for only half an hour. So I hope guys this stream will end within in a half hour. Yep. Guys, give me a second, and I will go and I'll come back. So let's get started. Back to starting. So oh, bye, bro. Go back to do your thing, bro. Go back to starting. Okay, I'm starting right now. Bye bye. Okay. Penicillin. It is the dull layered or elastical membrane made of gelatin which covers the whole body. Penicillin provides a fixed shape to the paracium, allowing them to squeeze, allowing to the screen uh, to be squeezed. It produces mechanical support and protection. Silica hair-like structure that helps in the locomotion. About 10K to 14K silica are represented in each paracium. There are two types of silica: oral silica, present in around oral group and base tube. The group of understabiling endostome membrane, which helps in the collection of food. Body silica, so, somastic silica present in uniform of all body surfaces except on posterior end where they are where they are in longer. The oral group is position back oblique and shallow depression present on ventrolateral surfaces. It extends downwards to the form vestibule. Full vacuole is non-contractive vacuole formed at the end of cytoparax, which gets separated and goes to endoplasm. Cytosis. Mhm. Cytosis is the process of momentum of food vacuoles along with with the cytoplasm in the clockwise direction for the digestion of the food. For the digestion of the food, uh, this cells journals of cytoplasm. It is the it is the minute of temporal opening from where the undigested food is acceptation. Internal cytoplasm is the clear transparent fluid where the organism are suspended. It is the differentiated into cytoplasm, thin transparent fluid that lies under the penicillin endoplasm, larger dense dynamic mass of cytoplasm. Endoplasm contains silica and thyrocytes and phytocyte endoplasm. It contains the endoplasm contains two contractile vasocalaries. Two nucleic acid is multiple food vacuoles trichocytes. They are small oval slack-like structure embedded with the cytoplasm. They are placed at the right angles to the body surface at the center of the anterior or posterior margin of hexagon depression or has the pores called trichocytes. Trichocytes opening. It consists of two parts. Spike, which is covered by a cap. Shaft. Shaft is a sac-like structure consisting of swelling substance or a fluid. Swelling substance or a fluid. Uh, it is discharge shaft which is longer thread-like structure with alternating dark and light cross bands. Trichocytes helps in the defense and the attachment attachment nucleus. The parasium shows the nuclear diphosium cells having two different kinds of nucleus, macronucleus and micronucleus. Difference between the micronucleus and macronucleus are macronucleus is large and being kidney shaped nucleus. Micronucleus are small spherical round in structure. Cells in middle lies in the concavity portion of the body. Macronucleus vegetative in function, reproductive in function. Contractive vacuole. It is the specialized type of vacuole that regulates the quantity of the water inside the cell or remove excessive water. They are temporal and can disappear periodically. Consists of contract vacuole. One at the anterior end lies near the nucleus, also called as nuclear vacuole. Other at posterior end lies on the nuclear peristome. So is it called peritoneal vacuole. Radicular canal, ventricular canal, thermal pores and collects water, and ampulla stores the water. Injectors sends the water to the contractile vacuole. There are 6 to 10 radical canals per vacuole. The vacuoles that work alternatively posterior contractile vacuole works faster than the anterior one. Ampulla completely empty and stored and completely filled distilled. Um, Food vacuoles are roughly spherical and non-contractile bodies containing small bacteria and other food containing along with this some small amount of water. They vary in the size number lying in endoplasm. They may be as many as 50 vacuoles at a time in a single peristome. The food vacuole circulates by the streaming of endoplasm around the body by clockwise clockwise direction is by clockwise direction. Nutrition is a mechanism of leading. Nutrition is a holozoic. Parasium feeds on small bacteria, yeast, protozoan, algae, and diatoms, and other small organic atoms, vegetables, and animals, omniviruses. They eat minute food particles only, so are also known as microspores. Filtration of food occurs in the vegetables, so only selective foods are passed on cytoparox called the filter feeding. So fieldings also called the filter feeder filter feeder feeding mechanism. When they are in rest, slowly moving the feed, which starts from the oral group, continuous beating of oral with silica produce water current, which consists of micro and micro food particles. Food particles then enter through oral group and vegetables, where the last food particles are rejected and thrown out of the oral group, where a small food particles only enters into a cytoplasm through the cytostome, finally settles down into reservoir. Finally settles down to reservoir. Okay, oxidation and reaction. Classical concept of reaction. According to the classical concept of reduction, oxidation is the chemical reaction which involves the addition of oxygen or electronegative radical, or the removal of hydrogen, or electropositive radical. Some example of are called as below: addition of oxidation, Na plus O2, Na2 plus O. Addition of electronegative radical, Mg plus Br2. Mg plus Br2 is Mg is oxidized to MgBr2. Removal of hydrogen, as Br plus Cl2 is equals to SCl plus Br2, means as Br is oxidized to Br square Br2. Wait. Means oxidation one. Okay, means the involving of addition of oxygen or removal. No. So, oxidation means that the addition of oxygen or 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 electronegative radical, or we can say that removal of electronegative radical, or removal of hydrogen is called oxidation. And reduction manifold opposite, the addition of hydrogen and electronegative radical, or removal of oxygen and electropositive radical is called reduction. बुझे यो अ, के भयो but I remember Prince as well. Dog, who are you, bro? एक घन्टा 1.5 घन्टापछि को आउँछ हौ पियुष भाइ हो के पारा वाट ओ electron method for balancing equation. During the redox reaction, oxidation and reaction occur simultaneously. In oxidation, there is loss of electron, and reduction there is a gain of electron. The total electron loss during the oxidation must be equal to the total electron gain but during the reduction. This is the principle of balancing reduction reaction by ion ion electron method. Rules: identifying oxidation numbers by all atoms present in the skeletal equation, but and put the number of top of the each symbol. Identifying oxidation and numbers and split the skeletal equation into oxidation half and reduction half, balancing both half separately as below. Balance atoms as H and O by adding integers, balancing O before the hydrogen by adding suitable number of H2O on the sides, whereas the deficiency of oxygen. Balancing H by adding the suitable number of H plus on the side of deficiency of hydrogen. Deficiency of hydrogen. Balance charge of addition of suitable 7 loud music रे 7 के भन्छ I think you guys can hear me. Okay, there is no loud music. Okay, bye. All right, Sandre, you don't even remember me. All right, Sandre, study Almod alone re. You got one viewer, that's me re. Peace 7 loud music, but I remember. Bro, what are you doing, gang? You got like. Thank you for the like, man. What the doing, bro? I remember you, but I don't want to say the name in the stream. Okay, let's get started. Let me just wait. Let me see the time. What is the time right now? So it is already 9 o'clock. Already 9 o'clock. Wow, so fast. So guys, almost let me see how much the time is left for 2 hours. Like almost 30 minutes is left for hitting 2 hours 2 hour mark. And I have like almost completed this amount of copy in a single day. So it is great. From yesterday and today I completed this amount of copy, read this amount of copy. Thanks so much. Probably I never do this live stream thing that I will not able to read this amount of book like copies. Shit, it's heavy. Oh, by the way, it's one is left. Let's read that, and then after I must close the stream and move towards the college. Okay, let's get started. So there's a not much left over here. So let's get started and complete this. Let's complete this whole copy and stop the stream. So we have already touched 1 hour and 45 minutes mark, and we gonna touch 2 hour mark, which is 15 minutes more. Let's do it. Okay, let's do it. Silicatoceans, algae, fungi, phyclogon, algae and mycetes, fungi and algae like fungi because they have characteristics similar to some algae, valgula in morphology and thallus and sex organ. Characteristics habitat mostly aquatic and some terrestrial nutrition, some parasitic and saprophytic structure, simpler conocytics, mycelium, asexual reproduction, endogenous and motile and zoospores, sexual reproduction in endospore, Example, mycore and gyrosporus, abgilos, etc. Characteristics of mycocytes, water molds or egg molds, mostly mostly parasite to the plants. Mycelium conocytic or hyphae wall, cellulose, kidney, and uh, gyclos. Sexual reproduction, zoospores or bisfactula. Sexual reproduction, mm, ooglogamous types that takes place by the Gametilius conapelius farming colospore. Example, Phytophthora infanius, obigulo, etc. Characteristics of zygospidicid, mostly saprophytic, rarely parasitic. Mycelium conocytic, well developed, and hyphae wall, kidney, motile cells absent. Sexual reproduction by Spirogoriosporus. Sexual reproduction by Gametilius Capillus, producing resting spores called example gyrospores and mycoeticis. Characteristics of psychomycetes, sac fungus, mostly saprophytic or parasitic, or saprophyngous, grow on the dung. Mycelium, septa and branch except the east, hyphae wall in kidney, and motile cells and absent. Vegetative, respectively, fermentous body, fishing, or sexual reproduction by uh, Condyla and Olidilla. Sexual reproduction, gameteneous opculus, sexual spores produced by insect sac. Um, Characters of Basidiomycetes, clove fungi, saprophytic or parasitic. Mycelium, highly developed, and septa consists of primary, secondary mycelium. Spore septa formed. Vegetative reproduction by fermentation. Sexual reproduction by Olerida and Coronida. Sexual reproduction by Omagotigami. Mostly advanced fruition stars, means mostly advanced fruitinization. Okay, fruitinization state. Characteristics of the deuteromycetes, sexual reproduction by absent or unknown example, mainly terrestrial. Some may be saprophytic or parasitic. Mycelium, septa, branch, hyphae. Vegetative reproduction by fragmentation or sexual reproduction, Conidida and Olidida. Chapter Mycor, classification of Mycor, kingdom Mycota, division Mysphagia, class Zygomycetes, order Microchorus, family Microcheires, and genus Mycor. Mycor is a commonly called pin mold or black mold or dung mold. Guys, give me 1 minute, okay? So give me 1 minute. Saprophytic fungus that grows on the bread and jam and jellies and animal dung, etc. Saprologos or mycor. Vegetative body is made of long ferruginous concytic hyphae. Structure of micro reproduction, sexual reproduction, asexual reproduction, vegetative method are fermentation, asexual formation is sporous formation, and sporangiospore is familius duospore olidira, which is olidira. Mm. Sexual reproduction in microcore occurs by conzilla or dimertaneous copulation. Heterothallic fusion between the hyphae of wall in different mycelium. Mycore is a mycore and mysodes etc. Fusion between the hyphae of some mycelium is mycore and femulus etc. Gymodospore remains dominant until the favorable condition is obtained. Means until it gets a favorable condition, it stays forever and never dies. त्यही त भन्नु खोजेको। So finally, guys, I have completed my all copies, which is total copy कति भयो? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of copies I have read on this date. That's crazy. Thanks so much for being on stream. Let me see how much time is left for 2 hour mark. We got about about 7 minutes on the screen. On the screen, it's showing like that. To hit the 2 hour mark, let's get started. First of all, so by the way, who is this Jack Tony? I don't know you gang. So yeah, damn. आउँदै यार अरू के पढ्न लाग्यो र 2 घन्टा हुन लागिसक्यो पढ्नु पर्यो नि इङ्ग्लिस छ कि छैन बे ओ प्र्याक्टिकल पढौँ न हौ साला आज सोध्छु भने भने okay Parasinium canodita distribution of habit composition of free living and standard fresh water fresh water. So this is my practical, by the way. So yep, you can see that. Sorry. By the way, who is that for giving like? Thank you so much. This is my practical, by the way. I don't know you can guys see this or not. Hope you guys can see this. Please don't say vulgars on chat, please. Distribution and habit compilation of a free living standards free water living organism rich in decaying matter decaying matter. Let me see that you can guys see me or not. Yes, you guys can see me and you can hear me too. Let me see you loudly. So guys, can you hear me or not? Yep. Yeah, literally like 6 minutes left. So let's get started with this stuff. Distribution of habit
Conospanidius and free living of standardized free water living in rich decaying organic matter, morphology and size, sleeper size shape and size ranges about 0.06 to 0.3 mm of size. Silica body is covered by a thin rigid elastical membrane formed by a Zittalin protein that's maintains its shape, maintain its fixed size. Locomotion moves by numerical hair like silica with longer silica at the posterior forming or candidata top. Nuclear binucleic acid with the nuclear diphonology. Nutrition and feeding. Holozoic nutrition using feeding apparatus and oral globe and vestibule and cytosome and cytoparax. Respiration occurs through the general body surfaces, production asexual by transfer transfer vascular binary fission and sexual by conjugation. Identifying features: slipper shape and two star shape, contracted vacuoles. uh, Economical importance helps in the control population of algae, bacteria and other water degradation of protists. Classification: the phylum Protozoa, silica, flagella, and absent in the silica, class silicata. This is the cytoplasm organelles. Ectoplasm contain cytospheres for defense, offense, and anchoring. Endoplasm contains nucleus, food vacuoles, and contracted vacuoles. So, also regulation and secretion. Differentiated into outer defense cytoplasm, inner thick granulous endoplasm. Endoplasm. Can be no, that cannot be seen though. You cannot do that. So guys, we are almost gonna hit the 2 hour mark stream. Actually, I was started this stream for 2 hours 15 minutes, but it's not quite possible. Because after 9:30 in Nepal, I must be ready for my college, so I need to go college soon. So thank you so much for watching this stream. Whoever are watching or whoever were not watching or who were not watching on the stream but watch it later. I hope you guys were watching the stream along. So yeah, almost 1 minute left. For the video, we have reached the 42% of my battery percentage. It is currently charging right now. It's not good, but thank you so much for being over here. Now we are almost gonna we're almost gonna hit the 2 hour mark soon in next 30 seconds. So that's great. Okay. An important thing that I want to say is that on this evening, when I will return from the college, I will start the stream on like in 7 p.m. or 7:15 p.m. That in that stream, I am I'm gonna do doing homework and completing my homework stream. That stream will be almost like about like 4 hours or 3 hours stream. I don't know about that, but yeah, let's get started with this. And thank you for your support was crazy. Whoever like this stream, thank you so much. And yeah, we have finally reached the 2 hour stream. Thank you so much, y'all. And bye bye. Thank you so much, guys. Thank you so much. And I'm ending in 3 seconds. Three, two, one. Peace.